Good morning. Today I'll be teaching the first part of your module 3, that is Introduction to Embedded System. As we all know that in day-to-day life we are becoming more and more dependent on embedded system, and our embedded systems are bonded into our daily activities even with or without our knowledge. So some of the embedded systems that we use in our house are refrigerator, washing machine, micro oven, air conditioner, TV, DVD players, music system, mobile and many more. Apart from all these embedded systems, even in our vehicle we use few of the embedded systems. Thus, in our vehicle we'll be making use of headlamp controller, engine controller, ignition control system, complex airbag control system that are used to protect us from the accidents, etc. So all these embedded systems will provide us comfort. So we enjoy all this comfort provided by this embedded system, and most of us are unaware of all these embedded systems. So in this module we will be learning in detail about one or two embedded systems. So before going to that, let us start with the definition of an embedded system. If we define an embedded system is an electronic or electromechanical system designed to perform a specific function, and it is a combination of both hardware and firmware. Firmware is nothing but a software. The most important thing is specific function as well as hardware and software. Meaning, embedded system. Embedded system means putting it together. That is hardware as well as software put together. Hardware and software put together to perform a specific function or a particular function or a particular task is nothing but your embedded system. That means if I take a washing machine as an example, washing machine is a combination of hardware and software, and the hardware used in washing machine are for example we can say hardware used in washing machine are display unit and timer to set up the time of washing, and we have a spin tub, and we have power supply, we have motor to control the spin tub, and we have sensors, we have actuators. Actuators are the one which converts an electrical energy into a physical action. So all these are our hardware. All this hardware has to be put together to do the specific task of washing. All this hardware together should do the task of washing. To make all this hardware to do the task of washing, we require a most important hardware, that is microcontroller. As we all know that microcontroller is nothing but a computer built on a chip. Entire computer we can find on a small chip. That chip is nothing but your microcontroller. If I have a microcontroller, I need to program the microcontroller to do the task of washing. This programming is nothing but your software. So what is an embedded system? If I take a washing machine as an example of an embedded system, it is a combination of all this hardware and a software. Software in the sense programming the microcontroller to do the specific task of washing. So combination of hardware with the software to do the particular task of washing is nothing but your embedded system. So that means 3. And the next is the difference between the general purpose computing system and an embedded system. This is an important. They'll ask the difference in an exam. So general purpose computing system is nothing but your desktop computer. Desktop computer or a laptop, whatever you use at home, is nothing but your general purpose computing system. Embedded computing system or an embedded system is, in embedded system we also have a computer. Where do you have a computer? The microcontroller is nothing but your computer used inside the embedded system. Microcontroller is nothing but computer built on a chip. So we have a computer in the embedded system as well as the computer that we used in the desktop. The difference between the computer and computer used inside an embedded system is what we learn now. The first difference is in the desktop computer, it is a combination of generic hardware and a general purpose operating system for executing variety of applications. That means a desktop computer will have a hardware. As I told now, the hardware used is meant for doing some general purpose application. That is, and we have a general purpose operating system. These operating systems are used for executing varieties of applications. That is, varieties of application that we see in a desktop computer is, I can use a desktop computer, I can connect the desktop computer to the printer and take a print of a text, or I can connect the desktop computer to the scanner to scan, I can use a Microsoft Word, I can use an Excel, and these are all the applications that are used using the desktop computer. So desktop computer is used for doing multiple tasks, not a specific task. So embedded system, the embedded system is a combination of specific purpose hardware and an embedded operating system. Embedded operating system is used to do the specific task. For example, as I explained, washing machine, if I consider as an embedded system, that is used to do the only the specific task of washing. And if I take a micro oven into consideration, micro oven is used to do the specific task of heating. So we have an embedded operating system which is used to perform a specific task. That type of operating system is nothing but an embedded operating system. We find an embedded operating system, whereas here we find a general purpose operating system. This general purpose operating system is used for doing multiple tasks. This embedded operating systems are used for doing only the particular task, that is specific task. And the second is, it contains general purpose operating system and may or may not contain. As we all know that operating systems are costlier, so general purpose desktop computer should have an operating system. The user can change the operating system from one operating system to another operating system in desktop computer, whereas in embedded system it is not mandatory that every embedded system should have an operating system. So you may or may not have an operating system, because since an operating systems are costly, if I go into the lower cost embedded system, operating system need not be present. So applications are alterable by the users. That is, I can keep switching. Applications are alterable by the users, meaning when I am using the desktop computer, when I am watching a video, I can stop the video and I can use it to play a game. I can stop playing the game and I can perform the task of writing a document. I can stop writing a document, I can perform some other task. So user can keep changing its applications. So user has a applications are alterable by the users, whereas in embedded system the software that is being programmed, the microcontroller whatever we program will be done by a manufacturer. User will not have any right, or a customer cannot change the program of the microcontroller. That is, the microcontroller that is used in washing machine cannot be changed to do the other task of heating. That is, the microcontroller for washing machine cannot be used in a cannot be used in micro oven. So the firmware of the embedded system or the software of the embedded system is pre-programmed by the manufacturer, and it is non-alterable by the end user. End user cannot change the program. We cannot keep changing the program of the microcontroller in embedded system, whereas in desktop user have a right to write a program and change the applications. Next is, performance is a key deciding factor in the selection of the system. So if I go to the market, we always give importance to the laptop or a system which is faster. We give importance only to the speed, more important to the speed of the computer or a speed of the laptop. So performance is a key deciding factor in a desktop computer or a laptop. Whereas in embedded system, we will not only look into the performance, we look into the performance, power requirement and memory usage. We look into the what power that is been consumed by an embedded system. So what are the key deciding factors of performance, power requirement and memory usage are the key deciding factor, whereas here only performance is a key deciding factor. The next is less tailored towards the reduced operating power requirement. That is, in desktop computer, we give more importance to the task performed rather than the power consumption. Whereas in embedded system, we give importance to the power saving modes. We also equally give importance to the task as well as performance as well as the power that is consumed by the embedded system. To reduce the power consumption, we have many power saving modes that have been embedded in the embedded systems. And the sixth one is the response requirement are not time critical. Response time is nothing but as soon as you give an input, the immediately it has to produce the output. That is a response. That is, if even though if there is a delay in producing an output, the delay is acceptable in the desktop computer. But in embedded system, in certain embedded system, response time is very much important. That is, in example, in a mission critical system, for example, if I take a braking system in the car, as soon as you apply a brake, the vehicle should immediately stop. If there is a delay in stopping the vehicle, it may lead to the accident. So immediate response is very much required in certain embedded systems. So response time or a deadlock or a dead time or a time constant is very important in an embedded system, or a response time is not very much important in desktop computer. These are the differences between a general purpose computer as well as embedded system. Going to again the difference between general purpose computing and the embedded system is this general purpose computing system will have a generic hardware, this have a special purpose hardware. It has a general purpose operating system, it has an embedded operating system. This is used to do variety of application, but it is used to do only a specific set of application. This contains general purpose operating system. It may or may not contain the operating system. Applications are alterable by the user. That is, user has a right to change the program of your desktop computer. Whereas in embedded system, the programming will be done by the manufacturer. User will not have any right to change the program of the microcontroller. Performance is a key deciding factor, and not only performance, power requirement and memory usage are all these three are the key deciding factor of the while selecting the embedded system. So we are give less importance to the power consumption, we give more importance to the task performed in case of desktop computer. Here we are equally give importance to the power consumption by the embedded system as well as performance. Here response time is not very much critical. Here response time is very much critical in some of the embedded system like mission critical system as well as in some of the braking system, as I told. These are the few difference between this general purpose computer and embedded system.